Students, welcome to this video. Today is very special day for all of us. This is Independence Day. So first I will express everybody happy Independence Day. In this video we are going to discuss the electron gain enthalpy and its variation in the periodic table. That is how it varies across the period and down the groove. Before going to that, let us understand what is meant by the electron gain enthalpy. Electron gain enthalpy is basically when we add one electron to an isolated gaseous atom. In that case, in that process, in that reaction, the neutral atom has been converted into the negative ion, and that is accompanied by a enthalpy change, and this enthalpy change is called the electron gain enthalpy. So we can write this in the reaction format. That is, suppose this is a X atom, and this X atom it has been given one electron. One electron is being added and it is become this negative ion, and in that process there is a change of enthalpy. This change of enthalpy is called the electron gain enthalpy, and it is denoted by this del Eg. Del means there is a change, there is something change is there. This change in terms of the enthalpy, and this is called electron gain enthalpy. So we can write electron gain enthalpy, or it is also called electron affinity, EA. Electron affinity. Electron affinity. So both electron gain enthalpy and electron affinity is basically, that is the enthalpy change in the process when we add one electron to a neutral gaseous atom in the isolated state. At that time there is a change of enthalpy. This is called the electron gain enthalpy, and this is denoted by del Eg. Eg means electron gain. Eg means electron gain. So this is called the electron gain enthalpy. This electron gain enthalpy, we can also say it is the tendency of the atom to gain the electron. All the atoms, the elements, will not going to gain the electron easily, but there are some elements that it can easily take up the electron. Electron gain enthalpy, depending on the elements, it may be negative and it may be positive. Majority of the reaction you will find that there is a negative electron gain enthalpy. What do we mean by negative electron gain enthalpy? Let us understand. Suppose this is a reaction, and in this reaction there is a release of energy. So one thing in this any reaction, chemical reaction, you can say, you can observe that there is always a change of the energy. Either the energy is evolved or energy is absorbed. So in the reaction when energy is released, suppose this is a reaction where the electron has been put in the neutral atom and the energy is released, then we can say it is having the negative electron gain enthalpy. Negative electron gain enthalpy. Electron enthalpy, negative, means the energy has been released, and there are some reaction, some element you can see that energy has been absorbed. So in the ionization enthalpy, what we find, it will be always positive because we have to give some amount of energy to release an electron. But in electron gain enthalpy, when there is addition of the electron to the atoms, there may not be release of the energy or not. So it will have, when the energy is released, we will see that is negative electron gain enthalpy. As for example, suppose this is oxygen atom. When we give electron to this oxygen atom, it will become a negatively charged anion, and in this case the electron gain enthalpy will be minus 141 kilojoule per mole. So in this case electron gain enthalpy is negative. That is means that energy is released. That is means energy is released. Suppose we get this one, we again want to add one electron to this negatively charged oxygen. Then the reaction will be like this. This is become the di-negative, and in this case electron gain enthalpy will be a what? At that time you can see it is already negatively charged and we are putting the electron here, so there will be a repulsive force. You do not want to accept that electron. When you do not want to accept that electron, then what you have to do? You have to give some energy, and you have to give some energy, and at that given energy it will absorb that electron, this electron, and it will become the O2 minus, and at that case you will find the electron gain enthalpy will be positive. Here there is a release of energy, here there is a absorbed is energy is absorbed. So second case, first case was energy is released, then negative electron gain enthalpy. In the second case, this is when we put a electron in the O minus oxygen negative ion, and in that case you will find there is a absorption of energy, means energy is absorbed. So you can see energy is absorbed, and this is energy is absorbed, then electron gain enthalpy will positive. So now we understand when the electron gain enthalpy will positive, when the electron gain enthalpy will negative. Okay, understand? So now we are in a position to understand what is basically electron gain enthalpy is, and how electron gain enthalpy become positive and how it is negative. Now there is a type, so there is a two types, or we can say different type of electron gain enthalpy, that what we observe in case of ionization enthalpy. There is a first ionization enthalpy, second, third. In the same fashion it will have the different type of electron gain enthalpy, that is a first electron gain enthalpy, first electron gain enthalpy, electron gain enthalpy. When the one electron is put at that time, the enthalpy change accompanied with the reaction we will call the first electron gain enthalpy. When the two electrons put in this neutral atom, we will say that is the second electron gain enthalpy, and likewise there is a numerous electron gain enthalpy will be possible. So now we are discussing the first electron gain enthalpy, then we have discussed the second electron gain enthalpy, and like this way you can see there is a different type of enthalpy that you observe. Different type of enthalpy you observe. So now what is the units of enthalpy? Enthalpy has been present as we have understood in case of electron gain ionization enthalpy. The units of the enthalpy is kilojoule per mole, or it is expressed as kilocalorie per mole, or electron volt per atom. These are all the units of the electron gain enthalpy. So by the time we understand what is electron gain enthalpy and what is the type of the electron gain enthalpy, when electron gain enthalpy is going to be positive and when electron gain enthalpy is going to be negative, that we already understood. And another name of electron gain enthalpy, that is electron affinity, EA. So when it is first ionization enthalpy, we will say del Eg H1, del Eg H2, and third, for the third that will be H3. So that is all. Now we are going to understand what is the trend when we go across the period, when we go down the group, what will be the trend, that we will understand. Okay. Now we are going to understand what is the trend of the electron gain enthalpy of the elements across the period and down the group. Then you can see some elements has been given with their electron gain enthalpy. Okay. What is given as hydrogen in -73? That is electron gain enthalpy negative, whereas helium is positive, 48. So in the period number 1 you can see there is an increase in the electron gain enthalpy as we have observed. But in the group number 2, what you find that as we go across the period, you can see the electron gain enthalpy more and more negative as we go up to the fluid. But in the noble gas, this electron gain enthalpy is very high, because when you have to give lot of energy to put one electron. In the period number 3, you also find that as we go across, we will find that this is electron gain enthalpy is much more negative as we go from the left hand side to right hand side. Okay. Now in the group also you can see as we go down the group, the electron gain enthalpy is decreasing. Electron gain enthalpy is decreasing. In the group number 13 also you can see there is a decreasing trend. There is a decreasing means as we go down the group, the electron gain enthalpy is much less negative. As we go across the period, electron gain enthalpy is much more negative. But there is an exception you can observe. Here exception is this, you can see for beryllium and for beryllium you will find that electron gain enthalpy is very much high. For magnesium it is very much high. For the noble gas it is very much high. Okay. Why it is so? Now that we will discuss. Because of the reasons. What is the reason that we will discuss? The general trend you can see that if we go down the groove and go across the groove, there is a decrease of electron gain enthalpy and also there is a increase of electron gain enthalpy, but there is a exception. You can see the exception here. In these three elements, nitrogen, oxygen and fluorine, nitrogen is having, you can see, the positive electron gain enthalpy, whereas in the oxygen it is negative and fluorine it is negative. But if we see it's in the same group element, phosphorus, you will find that is a negative, here it is negative, and sulfur also you can see more negative and chlorine also more negative. But this is the reason. But in the other case you can see the carbon and silicon, you will see there is a decrease in the electron gain enthalpy. Lithium also you can see lithium and sodium decrease in the enthalpy, but here you can see there is a increase in the electron gain enthalpy. Means what is there? Normally down the groove there will be a trend of increasing the electron gain enthalpy will be much more less negative. Electron gain enthalpy will be less negative when we go down the groove. This is the general trend. But here you can see electron gain enthalpy has been more negative when you go to nitrogen, to phosphorus, oxygen, to sulfur and fluorine to chlorine. What is the reason behind it? Reason behind it, you see the second period element and its atomic diameter is very less as compared to the atomic diameter of phosphorus, sulfur and chlorine, and that is the reason there is a repulsive force of the between the more repulsive force between the incoming electron and your the already present electron. Because of this there is a very less diameter of these atoms. Okay, so this is the reason you can see that oxygen, fluorine and nitrogen, they have the less diameter as compared to the phosphorus, sulfur and chlorine. So it will have the higher negative electron gain enthalpy as compared with this. So this is the reason. Another reason that you can see electron gain enthalpy, there is 3-4 reasons. Number one, that we already answered, already see. The factors, we can write here the factors which influence the electron gain enthalpy. What are the factors? First factor, that is the atomic radius, and second factor is nuclear charge. And third factor, the electronic configuration. For the nitrogen, you can see the electronic configuration of the nitrogen. It is the half filled because nitrogen is 7 atomic number, so its electronic configuration like this. So this p subcell is half filled. Okay, and for this case also, beryllium and magnesium, you can see 2s subcell is completely filled, and in case of noble gas, you also see this is also completely filled. And due to this, when we give some electron, it will not going to accept that electron because it is already stable configuration, so it will not want to take up any further electron. So you have to give energy to this cause. Okay. So this is all understood. Okay, you have understood all the things that what is the trend in the electron gain enthalpy and the periodic table and how the electron gain enthalpy being influenced by all these factors: atomic radius, nuclear charge, and the electronic configurations. Okay, is an incorrect statement that we have to understand. First, the ionization enthalpy of nitrogen is greater than the oxygen. This is the correct one because the nitrogen has the most stable electronic configuration because its 3p subshell is half filled. So, one electron, to remove one electron from this 2p subshell, that is not easy. Second, electron gain enthalpy of the fluorine is greater than the chlorine. And third one, the ionization of the beryllium is greater than ionization enthalpy is greater than the beryllium, and this is also a truth. Electron negativity of the fluorine is greater than the chlorine, is also true. But here this is not true because electron gain enthalpy of the fluorine is not greater than the chlorine, because we already explained this fact that due to this very small size there will be the repulsive interaction when we give some electron. When we try to put some electron, there will be repulsive interaction as compared to the chlorine, because chlorine radius much more that it can able to accommodate an electron very easily as compared to your fluorine. That is the reason the chlorine will have the higher negative electron gain enthalpy than the fluorine. So you can understand this. So in this way you will find there will be questions will come, and this question that you have to understand how we will be able to answer it. So this is for today's video. In the next video we will discuss the electron negativity. So next video we will meet. Thank you very much for listening. Thank you.